Hello everybody, I'm making this video especially for you in case you missed class. This is the worksheet that I have. I will try to remember to upload it for you as a PDF so you can print it out if need be, or you can grab one from my room. So first of all, it starts off with explaining perfect squares. You guys know these already. 1 squared is 1, 2 squared is 4, then we have 9, 16, 25. The next one would be 6 squared, which is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and then 12 squared, which is 144, and so on. So same thing happens when you have variables, okay? It's just something squared. So x squared, and then the next one would be x to the 4th, x to the 6th, you would have x to the 8th, x to the 10th, so exponents must be, what do you think? They must be even to be a perfect square. Okay, to take the square root of something with an exponent, it has to have an even exponent. You guys know this. 25, this square root of 25 is read the square root of 25. Okay, and you know that the square root of 25 is 5 because 5 squared is 25. So the square root of 36 is 6 because 6 squared is 36. This is something that's easy to you, I know. It's just there. So the square root of 100, of course, you know, is 10. Square root of 49 is 7. These are easy. And then, of course, now we do it with some variables. So notice that when you have a variable, you're not taking the square root of the exponent, you're taking the square root of the whole thing. And when you take the square root of the whole thing, it just halves the exponent. So the exponent gets divided by 2, basically. Okay, so we have a to the 3rd power raised to the 2nd power is a to the 6th. Hopefully you remember your exponent rules. When you have a power raised to a power here, you multiply the exponents. So when we take the square root, we're dividing the exponents. So here we have m to the 16th equals m to the 8th because m to the 8th squared is m to the 16th. Y to the 10th, okay, is going to be y to the 5th power. We divide the power in half. And a squared is just a. You guys know that already. That's easy. Divide the exponent by 2. In the expression, square root of a, the sign here is called the radical, and the letter underneath is called the radicand. So the number or letter underneath is the radicand, and you know the radical is the sign. All right, simplify. These are easy. Okay, you guys can do these on your own. The top row. Well, I guess we'll do them real quick. Square root of 4. You guys know that's 2. Square root of 16 is 4. The negative square root of 100 would be negative 10. Of course, if the negative sign were under the square root sign, then we would have no solution, no real solutions. Okay, square root of a to the 8th power. Take the a and halve the exponent. Okay, this is going to be w to the 6th power. We're just halving the exponent. I'm going to write these ones underneath here for number 6. Okay, it's just a to the 3rd power. Take the exponent and halve it, and b to the 5th power. All right, when you have a number and a letter, just take the square root of the number, which is 9. So the square root of 9 is 3. And the square root of a squared is a. We kind of already know that from doing quadratics. Okay, we want the negative root here. And the negative square root of 81 is 9. And then we have m to the 64, so don't forget we want to have that exponent. That's going to be 32. Okay, positive root here, we want the 7, a squared, b to the 6th power. And then the last one here is going to be 11, x to the 7th power, y to the third power. And whenever you can, please pause the video and see if you can do them on your own and then let it play so that you can see if you can do these on your own. All right, we're going to simplify radicals that are not perfect squares now. And we have done this already. This is just a refresher. So the square root of 20, if we find factors of 20 where 1 is a perfect square and 1 is not, okay, and you want the biggest perfect square factor, so 4 would be the biggest perfect square factor of 20, then you take the square root of that one and it comes outside the radical and you leave the other one under the radical. So 27, square root of 27, well, we have the square root of 9 and the square root of 3. And 9 we can take the square root of, that's why it becomes a 3 on the outside of the radical. And the other radical 3 has to stay. This last one, the biggest perfect square radical, perfect square factor of 48 is 16. Okay, and that the square root of 16 is 4, and you leave the square root of 3. So again, try these on your own. Try to pause the video, and then come back to me. So the square root of 45, we have some factors. Let's see, 9 and 5, I think, would be. 9 would be the biggest perfect square factor. So 9 and 5. And we can take the square root of 9, which is 3, and we leave the 5 under the radical. The square root of 12, the biggest perfect square factor is 4, and we have a 3 left over. We can take the square root of 4, and we leave the radical 3. All right, 50. How about 25 and 2? And I do urge you to write it out every time, because you'll get confused on, did I take the square root of it already? Do I keep it outside the radical? Do I not? So just show all your work so that it helps you and helps me see what you're doing. So this is going to be 5 radical 2. All right, now we're going to do some variables. We have the square root of 8 to the 5th power. So the biggest perfect square factor of this would be, if it's an odd number exponent, would just be the next exponent below it. Okay, if it's already an even exponent, then it's already a perfect square. So we just take our exponent, the odd one, and just subtract it by 1, and that's how I get a to the 4th. And of course we need to make it a to the 5th, so we need to multiply it by 1 more a. Now we can take the square root of this guy because he is a perfect square. So there's my a squared, and there's my leftover a. So here we go. We have an odd exponent here, so we take x to the 1 less, which is x to the 8th power. Sorry, it's supposed to be under the radical. My marker is big. And then, of course, we have 1 more x left over, which would just be x to the 1st power. And I can take the square root of x to the 8th, which is x to the 4th power. Remember, have it. Make that look better. All right, and then we have that leftover x under the radical. All right, x to the 3rd, I'm going to write it below here because I have some more room. You can write it wherever you want. We have an x to the 2nd power and another x to make it x to the 3rd. Well, I can take the square root of x squared, which is an x. I'll write it over here, x. And then we have another leftover radical x. Okay. All right. So I think these ones are going to be on your own for the rest of this worksheet. So you're going to try those, and you can ask me questions when you come in if you need to. All right, let's see. Let's do the adding and subtracting radicals. So when we add radicals, if the radicands, remember the number underneath, those are the radicands, if they are the same, you can just add the coefficients. Hopefully you remember the coefficients are the numbers out front. Okay, so as long as they're the same, we're just going to add the coefficients. So the first one, the radicands are the same. You can see they're both 6, so I can just add the numbers out front, and I keep the radicand the same. So 3 minus 4 Well, that's a negative 1, hopefully you know that. And then I keep that radicand the same, almost like I'm adding x's, 1x, or let's do it like this actually. You don't have to write this, you can just look. 3x minus 4x, you subtract the 3 minus 4, you get a negative 1, and you still keep that x. Same kind of procedures there, okay? So number 2, we have the radicands are the same. Go ahead and see if you can do it. Pause the video. Okay, and I get a 1 radical 7 when I subtract. And of course that is the same as just radical 7, okay? Either answer is fine for me. And the first one can also be written as just a negative radical 6. In fact, if you're looking at answer keys anywhere, usually it will be in the most simplest form, which would be those. All right, number 3, guys, actually, yeah, I'll do number 3. Number 3 is, they're the same, and it's a negative 11 and another negative 11, and that's going to be a negative 22 radical 21 because we keep the radical. I'm going to continue doing the odds here, and you'll do the evens on your own. All right, number 5, radicands are the same, so I'm just going to combine my coefficients. A negative 10 and a positive 12 is a positive 2 radical 7. Again, you're going to do the evens on your own. All right, 7. Did we just do 7? No, I guess it was different. 7, we have a radical 11, and you're just combining the numbers out front, which is a negative 21. Pretty easy until they get to number 9, where the radicands are not the same. So the radicands, sometimes they can be simplified. So let's simplify this radical 24. So think of perfect square factors. I have, let's see, 6 and 4, I believe. I'm going to rewrite this like this as a 6 and a 4. And of course there's a negative 2 out front. And I'm going to rewrite everything here so I don't lose anything. Okay, so far it's all the same. And actually, sorry, I'm going to rewrite the 4 first, because we always write the perfect square first. Write the perfect square, and then the other one makes it easier to understand. So, and of course, this is multiplication here, right? 2 times a radical 24, it's just so that we can understand what we're doing next. This is going to be 2 radical 6 minus 2 times, well, we can take the square root of 4, which is 2, and then you have a leftover 6. So let me simplify that a little bit more. We have 2 radical 6 minus 4 radical 6. Now they both have the same radicand, and this is going to be negative 2 radical 6. Rewind it if you need to. We're going to do number 11. All right. We can change square root of 12 into some perfect square factors. We have a 4. Let me put the negative sign out front. We have a 4 and a 3. And then we have 3 radical 3. And this is going to be negative 2 radical 3 plus 3 radical 3, which is just a 1 radical 3, otherwise known as radical 3. And you won't always get things you can combine. So if you end up with something, let me just peek here. So I'm pretty sure all the ones that you're going to do is going to come out nice and neat like that, where you can combine everything. But sometimes you'll end up with something like this. You don't have to write this down. You can just peek at it for a second. So what if we had 2 radical 3 and we had 4 radical 3 and we have a 2 radical 2? Well, with the radical 3's we can combine, and I can't simplify the 2 any more than it is. So you would just leave it alone. So you can combine the radical 3's, which would be 6 radical 3, and you would just leave the 2 radical 2. That would be as simplified as you can get. And like I said, I don't think any of your problems are going to be like that, but on this worksheet that I have, the problems that I cut off, there's probably some like that. All right. Let's do the last thing, which is multiplying with radicals. Okay. We already talked about this. What operation is this right here? All right, this is multiplication. So I'm going to move this guy. Okay, so when we multiply radicals, let's look at our notes here at the top. It says, number 1, multiply the coefficients, the numbers out front. This is, of course, a 1 radical 6, so we would be multiplying a 3 times a 1. And step 2, multiply the radicands. Hopefully you remember that's the number underneath the radical. So we're going to multiply those two together, and then you will simplify. So starting this off, 3 times 1 is 3. Keep these under the radical. You can only multiply outside together, and then you multiply inside together. You can't multiply anything from the outside with things on the inside. Okay, so the 3 is on the outside, and on the inside we have 12 times 6, which is 72. And then we simplify that 72. So let me think. 9 and 8, but no, 8 still has another one in there. I'm going to show you what my brain is thinking right now. 9 times 8, but 8 still has another factor of 4 in it, right? So really, if I multiply my two perfect square factors, I get 36. So 36 times 2 is 72. So the biggest perfect square factor is 36. So I'm going to write this. 36, we have the square root of 36 and the square root of 2, and don't forget we have that 3 on the outside. And I'm going to rewrite that over here because I'm running out of room. This is multiplication, don't forget. So 3 times the square root of 36, which is 6, radical 2. My board's being funny. And that's going to equal 18 radical 2. Again, you're going to do the even problems on your own, so we're almost done here. Number 3, there's nothing on the outside to multiply because it's 1 times 1, which is still 1. But we can multiply the inside together, which is 36. And of course, you know the square root of 36 is just 6. Number 5, multiply the outsides together. A negative times a negative is going to be a positive 4. And multiply the insides together. 15 times 3 is 45. Make that look neater. And the square root of 45, let's see, I'm going to get a 9 and a 5 for my perfect square factor being 9. And the square root of 9 is 3, so don't forget this is multiplication. And 4 times 3 is 12. And I think that's it. Let's see. Oh, we have a few more we can do. I'll do a couple more with you. Oh yeah, I do want to do these ones. Okay, so the insides are the only thing we're multiplying here, so because there's nothing else on the outside. We have 15 times 10, that's 150. We're multiplying the ends together. Keep your base, add your exponents. Okay, so 150, oh my goodness, let's see. 150, how? 25 and what? 25 and 6, is it? 6, 4, yeah, 25 and 6. So 25 and 6, and of course the n to the 5th power, we did this earlier, right, is going to be n to the 4th, that's a perfect square, and then one n left over. Okay, so now let's pull out everything, we have the square root, here I'll highlight for you, the square root of 25 I'm doing, and I'm doing the square root of n to the fourth. Okay, so the square root of 25 is 5, the square root of n to the fourth is n squared, and then the other things stay under the radical, just keep them under one radical sign. So we have a 6 and an n underneath the radical sign. Again, always try to pause the video when you can and try to do them on your own, and of course you're going to do the evens on your own anyways. Number 9, negative 3 times 6 is going to be negative 18. Under the radical we have 49, 7 times 7, r to the 6th. Nope, fifth power, sorry, adding the exponents. All right, so we have this negative 18 on the outside. Under the radical we have, here. I'll just write 49 here. I'll write the r to the 4th power with another r left over to make it r to the 5th power. And now the perfect squares are here and here. So we're going to take the square root of those, which means there's no more radicals on them. The square root of 49 is 7. So I have left a negative 18 on the outside times a 7 because of the square root of 49 times an r squared because I took the square root of this guy, and then I have a remaining r under the radical. And I'm going to go ahead and finish this by multiplying these two together. Negative 18, sorry, I'm doing my calculator. We have negative 18 times 7, which is a negative 126 r squared radical r. All right, and the last two is we're going to use the distributive property. So we're going to distribute the 3, square root of 3. So remember, when I multiply this first thing, we'll do it in a different color. When I multiply this to this, I can only multiply the outside stuff together and the inside stuff together. So the stuff on the outside of the radical together, which is a 5 times a 1, because this is a 1 radical 3, so this is 5. And you would multiply any inside stuff together. Well, it's only just a radical 3, nothing to multiply it to. Okay, and then when I do my second one, now I do a 1 radical 3 times a radical 3. Again, the outside stuff together would be 1 times 1. And the inside would be radical 3 times radical 3, which is radical 9. Okay, to simplify this, all we have to do is take the square root of 9, which is 3, and this is 1 times 3, which is 3. That's it. All right, last one. Okay, remember, when we distribute, when we multiply, only outside stuff together and inside stuff together. So we're multiplying a negative 3 times a 2, because those are both outside of a radical. So this is going to be a negative 6. Nothing to multiply the radical 3 by, so it's just going to be radical 3. All right, erase this so it looks a little neater now. All right, now I got to multiply this guy to my radical 6. So nothing outside that guy except a 1, so it's going to be a minus 3. And I can multiply the stuff inside the radicals together. 3 times 6 is 18. Okay, radical 3 can't be simplified, so I can leave that one. But radical 18 can be simplified. So I'm going to leave this one. And radical 18, 9 and 2, I believe, would give me my biggest perfect square factor. And this is just going to be minus 3 times square root of 9, 3, radical 2. And so we have negative 6 radical 3 minus 9 radical 2. Remember when I said if the radicands are different, you can't combine them. That's as simplified as you can get. So you'll finish those worksheets